Okay guys, so today we're going to look at the average gradient of a curve. Last time we had a curve when we put a tangent through it. This time we're going to have a curve and we're going to use a chord to work out what the average gradient is between those 2 points. So let's get right into it. For the first example, we're told, calculate the average rate of change over the interval x equals -3 to x equals 0, and then 1 to 2. Okay, first and foremost, let's write it out. So x equals -3, that is here. So therefore it's this point here. -3, 2. And when x equals 0, that's going to be here. And the point is 0, -1. So what we can do is we can draw a chord between them. And then now we need to work out the gradient of the chord, which is just going to be change in y over change in x, which is -2, sorry, 2 here, -1, all over -3 minus 0, which is equal to -3 over -3, which is equal to 1. So therefore the answer between x equals -3 and x equals 0 is a rate of change of 1. Now, what about if it's between 1 and 2? Well, same thing. First and foremost, when it's 1, we need to draw it up. So this is 1, 2. And then when it's 2, it's gonna be here at 2, 7. We can draw a chord on it. Okay, that you're gonna have rulers and pens. I am using a computer. And then we work out the gradient of the chord, which is just the change in y over the change in x, which is 7 minus 2 divided by 2 minus 1, which is just equal to 5. And those are your final answers. Is this video making sense so far? Make sure you subscribe so that you never miss a video from me. Now, what about this one? For this one, we're told, calculate the gradient of the chord between 4 seconds and 8 seconds. So, it's the same thing as what we've been doing. So we find at 4 seconds, we know that this is 4, 1. And between 8 seconds, which is here, we got an answer of 5. So this is 8, 5. So the gradient is just going to be change in y over change in x, which is the same as 5 minus 1 all over 8 minus 4, which is 4 over 4, and that's equal to 1. Now, what does this gradient tell you? Well, let's take a look at what we have here. This y-axis represents the velocity, okay? And this axis here on x is the time, right? And so therefore the gradient is equal to the velocity over the time, which, if you remember from physics class, is equal to the acceleration. Yeah? We'll look at distance time graphs a little bit later when we start mechanics, but these are just some of the things that you have to pick up during the exam. But if that doesn't make sense to you, don't you worry. Just join my Discord server and send me whatever questions you want, and I'll answer them to the best of my ability. Now, what about this one? This time we're going to use all that we have used so far. So first and foremost, we need to calculate the average speed of this time graph between 0 and 8 seconds. So we know that at 2, we are here. So that's, if I can see from the graph correctly, 2, 4. And then at 8 seconds, it's going to be 8. Let's take a look. That's 1, 2, 3. No, looks like it's a 4th. No, it's 3. So that there represents 6. We can say that's 8:46. Okay. So therefore, the average speed is equal to the gradient. Because remember what this graph is. It's a distance over time, which is equal to speed. Anyways, so that's just going to be the change in y over change in x, which is the same as 46 minus 4 all over 8 minus 2, which is the same as 42 over 6, which gives us an answer of 7 meters per second. And let's write that down. Now, estimate the speed at 6 seconds. Now remember that for a chord, this is the average of just here to here, okay? If we want it at one point, all we need to do is draw a tangent at 6. So this is where 6 is. We can say that that's 6:24. I think that's a good educated guess. And then let's draw a tangent. Okay. This tangent goes through 6:24, but it also goes through 8:42. Okay? So now we can use that to work out what the average speed is. So average speed is going to be the change in y over change in x, which is just going to be 42 minus 24 over 8 minus 6, which is the same as 18 over 2, which is equal to 9 meters per second. Okay? It should be larger than 7, just because this is a lot steeper. So it should be a bit faster than it was in the first part. Now, Nuri says that I think this animal must be able to move at over 20 meters per second. Is she correct? Well, let's take a look. What we need to do in this case is find where the steepest point is. Okay? So I would say that the steepest point is roughly, I'm going to use a different color, around here. Okay? Would you say so? I would say that's pretty steep. And then what we're going to do is we're going to draw a tangent on this point. As you can see, the tangent is pretty much straight. And we can say that at 10 seconds, this point here is 10, what's that? 10:102. And it also passes through, if I extend that a bit more, 11,130, give or take. So therefore, we'll say that the max speed is going to be change in y over change in x which is the same as 130 minus 102 all over 11 minus 10, which is equal to 28 over 1, or 28 meters per second. So, is she correct? Yes, she is correct, because here we can clearly see that this animal did move faster than 20 meters per second. And that's it for today. Thank you guys for watching. If you guys want to pass your exams even better, drop me an email and you could get tutored by me. Keep on learning, as you have no idea what you're capable of doing.